All right, we are finally done with that massive unit on quadratics. Ended with a really hard section. I know people are feeling kind of overwhelmed with the class right now. The main thing that you need to retain from our unit on quadratics and moving forward is you have to be able to factor and you have to be able to do the quadratic formula. Those are the main key points. Our next unit is actually very short. We have very few formulas, and it's going to be a little bit more straight and to the point. We're not going to have to build and build and build as we go along. So we are going to have a small unit, just 3 lessons on square roots. And we're going to start by graphing square roots. So way back at the beginning of the year, one of our beginning projects was to graph the simple equation, our parent graph of y equals square root of x. So let's go back in time and graph y equals the square root of x. And you'll notice I'm using graph paper here, and I highly recommend that you use graph paper on most of the homeworks for these. It's a little bit easier, and we have to be a little bit more precise with this. Our basic graph of y equals x squared, when we graphed it before, hits 0, 0, hits 1, 1. And thereafter, we see a pattern of square roots. So 1, 2, 3, 4, square root of 4 is just 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. Square root of 9 is 3. So we get a pattern where it comes up. Now, one of the main mistakes I see people make when they graph these is they simply connect with a straight line, and that is incorrect. If we were to turn this sideways, this looks just like the parabola. And that is, in fact, one of the main relationships we're going to talk about later, is that parabolas and square root graphs are actually inverses. They're basically just turned sideways from each other. So we still need to draw it. In this case, it's going to start out coming straight up, and then it's going to curve in. So then from there, it keeps curving, it's still going out, and it's going up and up. Again, if we turn it sideways, that's looking like the left half of a parabola. So this is our basic parent graph. This is our basic y equals the square root of x. Now, there are certain characteristics of these that we need to look at. The first is we're going to go all the way back to our very first unit, our very first lesson. We need to talk about domain and range again. So when we look at this graph, it's starting at a key point here, and then it's going in one direction. So if I talk about domain, we have no domain over here. It doesn't exist. So my domain on this basic parent function is simply, and I'll show it a couple different ways. X has to be greater than or equal to 0. If we want to do in terms of interval notation, we could write it as 0 to infinity. And these are going to be kind of the 2 main options when I have you do domain and range. I want you to either use inequality notation or interval notation to kind of show these. So our domain is starting at 0, and it goes all the way right to positive infinity. So we're going from 0 to infinity. Our range. Well, range is again talking about the y values. We're starting with 0, and it goes up forever. So again, our range would be y is greater than or equal to 0, or again, 0 to infinity inclusive of the 0. So every time we graph something today, you have to show me the domain and the range as we go. Now, there are other key points. So this starting point here, just like it was with a parabola, this is still effectively our vertex. That's still the starting point. And in this case, our vertex is 0, 0. Now, I'm going to ask you certain things about all of our graphs. And that's what we're doing today is we're just graphing. So for one, I'm going to ask you to graph it itself. Use your tools and you do any kind of manipulations you need to do, but we need to be able to get an accurate graph. Second, I will ask about domain and range for each graph that we do. Third, I'll ask about the vertex, and I will also ask about any, not asymptotes, any intercepts. So we're going to have to tell me the x-intercept and the y-intercept. Now remember, intercepts are when they simply touch those axes. So the main way we solve it is the x-intercept is going to be some x value that yields a y value of 0. Just like our y-intercept has to have an x of 0 and then some matching y value. And that's going to be our key to actually solving these. It doesn't make a whole lot of sense on our basic graph, but I'll talk about that in a little bit more. Here, our intercepts are nice and easy. They're right there at 0. Where it touches the x-axis is 0. So my x-intercept is 0, 0. Where it touches the y-axis is 0. So my y-intercept is 0, 0. This is our basic parent graph. The other thing I will ask you to do is ask you to tell me how our other graphs compare to this one. Just like we've done in our previous units, just like we did with our absolute values, just like we did with our parabolas. A lot of those rules stay the same. So let's start looking at a couple examples of these. So we can take something and we can actually add or subtract a number to the end. So square root of x plus 2. Just like when we did our absolute values and when later on when we did our parabolas, adding a number to the end still results in a vertical translation. It's just moving the entire graph up or down by that amount. So if I had a graph y equals square root of x plus 2, I'd have a vertex starting right here at 0, 2. We'd go 1 and 1, 1, 2, 3, 4, and up 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, and up 3. Again, when I plot it, I start by coming straight up and then curving over. And I have my graph. So there's my graph of y equals square root of x plus 2. If I go over all of my key points, there's my vertex. My vertex has been moved up 2 units, so it's now at 0, 2. My domain, well, that didn't change. It's still starting at 0 and going to the right. So my domain is still 0 to infinity. My range, that has changed. My range starts at 2 and then goes up forever. So my range is now 2 to infinity. X and Y intercepts are now different. My x-intercept, well, look at that. It never touches the x-axis. There is none. My y-intercept. Y-intercept is touching right there at 2. So my y-intercept is 0, 2. So that gave us all our kind of information we need for that one. So let's look at some other kind of changes we could have. So we know that adding and subtracting numbers is going to move the whole thing up and down. And same thing is true, just like we did before, adding or subtracting a number inside is going to shift us left and right. So let's try one of those. So how about if we had y equals the square root of x minus 3 plus 2. Okay, so we can go start graphing this. The plus 2 was easy enough. That's just going to move us up 2. And that minus 3 inside is going to do exactly what we've seen before. It's going to shift it in the opposite direction. So this is going to be a shift right 3 units. 1, 2, 3. Up 2 units. And we're going to be starting right there. From this point, we're still going to go up and over 1. 1, 2, 3, 4. 1, 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3. And we still have that classic starting up, curving over, and we have this as our graph. All right, so vertex. Our vertex is now here at 3, 2. My domain, well, now we're not at 0. We're starting over here at 3, so my domain is 3 to infinity. My range, we're starting right here at 2 and then going up. So my range is 2 to infinity. All right, x-intercept. Well, we're starting here at 3 and 2, and then it goes up. There is no x-intercept in this case. Y-intercept. Well, our y-intercept, we never go back in time. We never go backwards and hit that. So there's no y-intercept either. Now, if I wanted to tell how this was compared to our other graph, that's just what we would do before. So this graph has been shifted 2 units up. It has been shifted 3 units right. Okay, so all these are pretty straightforward. We can still move it up and down. We can still move the graph left and right. There are a couple other changes we can do. So let's try our most basic other changes. How about y equals 4 square root of x? Putting a multiplier in front, just like it was when we did absolute values and parabolas, is actually going to be a vertical stretch or a shrink. In our parlance before, sometimes we've talked about making fatter or narrower. A little more technical now. This is going to be described more as a vertical shrink or an enlargement. So all this is going to do is it's going to maintain the same ratio. So we're still starting here at 0, 0. Our vertex has not changed. But instead of going to over 1 and up 1, we're going to go over 1 and up 4. 1, 2, 3, 4. Instead of going over 4, 1, 2, 3, 4, and then up 2 like we did before, now we'd have to be going up 8. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. And I don't even have enough room for the next. If we went over 9, normally we'd be up 3, but now we'd have to be up 12. So now our square root function is looking something more like this. So we can still look. So our domain, we already identified our vertex as 0, 0. That didn't change. Our domain is still at 0, goes to the right, 0 to infinity. Our range is still going from 0 to infinity. Our x-intercepts and y-intercepts, we're touching both axes right there, so we're about 0, 0 with both. So all those still work out. And to describe this, now we could say it's going up faster. So we did not shift it left or right. However, we have done a vertical stretch. We've stretched it vertically. I'm going to turn on some light here. It's a little better. So if we applied one of our other ones, if we had given a value less than 1, say 1/3 or 1/2, it would have actually compressed it down. So on the same axis, if I were to do 1/2 square root of x, instead of going over 1 up 1, we'd go over 1 up 1/2. Instead of going over 1, 2, 3, 4 and up 2, we'd be only at 1. 1, 2, 3, 4, 5, 6, 7, 8, 9. Instead of being up 3, we'd be up only 1 1/2. So we'd end up with a much, much more compressed square root function like that if we did those. So that's kind of what's happening as we change the number in front. What about negative? Well, if we had negative square root of x, well, this one's going to be a little bit different. Negative is actually going to flip us upside down. So still starting at 0, 0, there's my vertex. We haven't moved it left or right. But now, instead of going over 1 up 1, we'd go over 1 down 1. Over 4, 1, 2, 3, 4, down 2. Over 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, down 3. And we ended up with something looking like this. So all of those still apply in how we've done them before. We still have kind of this basic idea of something like a times the square root of x minus h plus k. Like this kind of idea still works just fine. There's just one caveat. There's one little strange piece to this. So just like we can change it by stretching it vertically, by putting a number in front, we can also mess with things horizontally. And that's going to be a little bit weirder to look at. So the way that's going to work is by having another number inside here. So this is kind of how I like to think about square root functions, is this other number inside. So we still have our shift left or right of h. We still have a shift up or down of k. A is still going to spread us up faster or slower or flip us upside down. What this number is going to do is essentially either stretch it sideways or compress it. So very similar in how this worked, but it can also completely reverse the direction. So let's kind of look at one example of that. Let's say we wanted to graph y equals the square root of negative x. And I know the first thing you're thinking is, well, we can't take the square root of negative. Well, this isn't the square root of negative, this is the square root of negative x. If we were to plot these, what would end up happening is we still start here at 0, 0. But if I were to put in something like x equals 1, that doesn't work. It doesn't exist. If I were to put in x of, say, -1, my matching y value is negative and negative is just 1. Square root of 1 is 1. So it ends up flipping our whole thing, 1, 2, 3, 4, 1, 2, to go in the other direction. 3, 4, 5, 6, 7, 8, 9, 1, 2, 3. So by having this negative inside as a coefficient, we actually are reversing the entire direction of our square root function. So let's try putting kind of one of these all together. This is basically your homework is just graphing, and then identifying vertex, domain, range, x-intercept, y-intercept, and vertical stretch. I'm going to do one more basic graphing example, and then I'll talk about weird things that can happen with the intercepts and how to find them. So let's finish up this guy here. So our domain in this case is it's going left forever. So we're going from -infinity all the way up to 0. My range is still 0, and we're still going up. That's still 0 to infinity. Oops, need a bracket. X-intercept is still 0, 0. Y-intercept is still 0, 0. And then if we wanted to talk about how this compares to the parent graph, we have a couple different ways we can say. We can say it's a reflection. Probably the easiest way to say it is a horizontal reflection. We can be more specific. We can say this is a reflection through the line x equals and then whatever our value for the vertex is. So let's kind of do that for the moment, because that's actually our most direct and accurate. So this is a reflection through x equals, and I put my x value of the vertex 0. Remember, x is 0 would be right here. So if we use that as our mirror, our normal one would be this way. It would then bounce us back the other. All right, so let's kind of take a look at what can happen with our other graphs here. So let's kind of put it all together and try to do one kind of more complicated example here. So let's say we had the graph of y equals -2 the square root of x plus 3 minus 4. Nice big ugly thing. All right, so we go to graph this. This is a square root function. I'm going to draw this one kind of bigger this time, because we're going to do a little bit more with it. So this graph has been shifted left 3 units, 1, 2, 3. It's been shifted down 4, 1, 2, 3, 4. There's my vertex. It is going downward, but notice there's no negative inside here, so it's still going to the right. So negative out front moves us down or up. A negative inside tells us left versus right. So it's positive inside, we're still going to the right, but a negative outside, it means we're going to go down. Normally I'd be over 1, up 1, but instead of the -2, I'm over 1, down 2. Over 4, 1, 2, 3, 4, down 4, 1, 2, 3, 4. If it was a 9, normally it'd be 9 and 3, and this time it'll be 9 and 6. 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6. So we'd get something that looks like that. Now, a lot of this seems pretty easy, but that intercept might be a problem. So let's get the rest of our information listed. So a vertex, we know that from kind of doing our HK stuff. Our vertex would be -3, -4. That's straightforward. That's right from these guys. Our domain, okay, domain is pretty easy. That's starting right here at -3, and it goes right forever. So there's my -3 to infinity. My range would be from, all right, so we're going down forever. So that's -infinity all the way up to our highest point we reach is -4, inclusive. Okay, comparing to our regular graph, this has been shifted 3 left, 4 down. It's upside down, using the terminology we used before. and faster or steeper, or our proper language would be a vertical stretch. Now, our next problem is our intercepts. So let's kind of look at intercepts in more depth. Our basic idea of our intercepts involve that one of the values has to be 0. So again, when we set our x-intercept, if it touches the x-axis, our y has to be 0. Our y-intercept, that's where it touches this guy. The only way that can work is if the x is 0. So if we can't visually see it super easier, we use a tool or a graphic calculator and we get some kind of weird number, then that means we actually need to find it. So let's actually show what happens if we try this process. So to find the x-intercept, we're looking for the x value for when y is equal to 0. If we're looking for the y-intercept, we're looking for the y value when x is equal to 0. So let's actually try these out. So remember, our basic formula that we have here is y is -2 the square root of x plus 3 minus 4. So let's say we want to find a y-intercept first. So on a y-intercept, x is 0. So I'm going to plug in a 0 for x. -2 the square root of 0 plus 3 minus 4. At this point, all we need to do is simplify. So that gives me y equals -2 the square root of 3 and then minus 4. That's nice and simple. That's actually our legit intercept. -2 root 3 minus 4. This would be the proper answer then. For my y-intercept is 0, -2 root 3 minus 4. I'm not going to be too mad if you dump that into a calculator and get a decimal. It's going to be around 2, 3, 4, 5, 6, like 7 and just a little bit more, like 7.1-ish or so, 7.2, somewhere in that range. But this is our actual y-intercept. X-intercept is a little bit more challenging. We're going to get a lot more into that later. So let's say we tried the x-intercept. If we're doing the x-intercept, we need to plug in a y value of 0. So let's do that. So then I'd have 0 equals -2 the square root of x plus 3 minus 4. Okay, this isn't too bad. So I can add 4 to both sides. That gives me 4 equals -2 the square root of x plus 3. I can divide both sides by -2, and I get -2 is equal to the square root of x plus 3. And this is where you need to be careful. For the most of our work, when we take a square root, we can't have a negative answer. There's only specific times when we're allowed to do that. This is not one of them. Our square root never gives a negative. So you could keep solving this process and you'll get a number, but that number is corresponding to the other half of that sideways parabola. That's why we can possibly get something else and we'd get a value up here, and that's no go. We're only dealing with this part of the square root here. So be very careful. So right here, I would write no x-intercept. Square root of the number is not going to yield the negative version here. To solve this, what we would actually do is we'd square both sides, giving me 4 equals x plus 3, and then we'd subtract 3, and we'd actually get x equals 1. The problem is that is the solution to the other half of the square root, the other value that forms our sideways version of the parabola. We don't need to worry about that. So just be aware when you go through to solve for your intercepts that you're not falling into this trap. If you see your square root has to be a negative, or if you've already graphed it and you can see it's not going to intercept, then you're done. You just say there's no intercept. We don't have to have it. All right, that's basically all we have for our opening lesson. It's just a whole bunch of graphing, and that is it.